In this video, we're going to look at graphing two trig functions from the homework, and these are the 5 steps that I'm going to follow. So first, let's look at this equation. Step number 1, I'm going to find the midline. The midline is going to move if there's a number that I'm adding on to the end of the trig function. So since there is no k value, as we're going to call it, the midline should just stay at y equals 0. So right here, the x-axis, that's my midline. Second step, now we're going to outline the range. So I want to look at the a value. Is there some number out front that I'm multiplying the trig function by? And here it's just 1. So if there's nothing out front, it's like there's a 1. That means that your amplitude is 1. So I'm just going to kind of outline the range. The range is going to stay the same as the parent function, y equals cosine of x. And the range would just go from -1 to 1. So right now I have the midline, I have the range. The domain should be anything. I can take the cosine of any angle measure, positive, negative, 0. Step number 3. Now I'm thinking, where would the y-intercept of the parent function move? I want to look at the h value. So that would be right here. Is there something that I'm adding or subtracting onto the x? Yeah, so it looks like I'm adding pi radians to the x value. If I'm adding pi radians, that will actually shift the y-intercept pi radians to the left. So if I think about my parent function, y equals cosine x, the x-intercept would be at 0, 1. So now this, or the y-intercept, excuse me, would be at 0, 1. This y-intercept, that point, is now going to actually move pi radians to the left. So instead of being up here, this point is going to move pi radians to the left. At this point, I'm going to actually label the x-axis. I've labeled so every dash is pi over 6 radians. And I'm saying, okay, well this that used to be the y-intercept of my parent function, that's now going to move pi radians to the left. So that's going to be kind of my new starting point. And from there, next step, I want to know what the period is. So I want to look at the b value. Well, am I multiplying this angle measure by something? Yeah, I'm multiplying it by 4. So to find the period, I should take 2 pi divided by that b value. And in the end, I get pi over 2 radians. This means that the next peak to complete one cycle should occur pi over 2 radians after this point that I just plotted. So pi over 2 radians, well, that would be, I'm here, pi over 6, 2 pi over 6, 3 pi over 6, or pi over 2 radians. That would be the point where the period finishes. So in between, I should hit the low point. And in between the high and the low point, in between the max and the min, right about there, I'm going to cross the midline. Same thing here, between the min and the max, I'm going to cross the midline. And then that would be one complete cycle of this cosine function. From there, okay, so pi over 2 radians is the period. So just every 3 dashes, or every pi over 2 radians, that's where I should see the max. So I'm just going to go 3 to the left, 3 to the right. In between, I should see the low point. So in between there, I should see the min. And then just connect with that nice sinusoidal wave. Make sure you're not drawing straight lines. They should be curved. And this is the last step, just complete once I have found that one cycle. So here's the first cycle that I drew, just repeat, and then you have the graph of your function. Make sure you have arrows on the end to indicate that this goes on forever. Now just a couple quick checks. This b value, this 4, means I should see 4 cycles. 1, 2, 3, 4 cycles in 2 pi radians. Sure enough, I do. You could also make a table. So I just plugged in a couple of x values. Let's say I plug in 0 for x. And I also plugged in pi over 2 radians for x. So if I just input those into the function, see what comes out, this tells me that those 2 points, so 0 radians 1, pi over 2 radians 1, these 2 points should be on my graph. If I look back, sure enough, here they are, 0, 1. Pi over 2 radians would be right here, pi over 2 radians 1. Yep, those points are on the graph. So I'm fairly confident that I have the correct graph. If you're still not sure, you can go to your graphing calculator, type in your function, make sure you're in radian mode, and then when you graph it, just go to a zoom trig, and that should give you a window. Your x min, x max should be pretty close to negative 2 pi to 2 pi, which is similar to the graph that I gave you. Next graph is number 7. So let's refer back to the steps. First 2 steps, I want to find the midline. So look to see if there's some number I'm adding on to the end of the trig function. And then I want to outline the range. So see if there's a number out front that I'm multiplying the trig function by. So step number 1. There's no number that I'm adding or subtracting to the end of the trig function. So actually for this equation also, the midline should be the x-axis. So midline is still y equals 0. And then there is a 3 out front, which means the amplitude is going to change. So I'm going to be graphing my trig function. It should end up 3 units above and 3 units below the midline. That gives me my range. So that kind of takes care of that a value. Now I'd be looking at, is there some horizontal translation? Is the graph is a parent function being moved left or right? Yes, it is. If I have that x minus pi over 4, that means the parent function, along with this vertical stretch, everything's going to be translated pi over 4 radians to the right. So now I'm going to mark off the x-axis again. And I'm going to think about what my parent function y equals sine of x looks like. So for my parent function, y equals sine x crosses through the origin, crosses through the point 0, 0. So if I think of that starting point, well, if I multiply that by 3, 3 times 0 is still 0. But this point is going to be translated pi over 4 units to the right. This right here is pi over 2. So pi over 4, or a quarter of the way to pi radians, that would be about right there. That's going to be my starting point of this graph. So I want to start here. Then I want to draw in 1 cycle using the period of the function. So I'm not multiplying the x term by anything, which means the period on this function is the same as the parent function. It should just be 2 pi radians. So on my graph, it looks like what every 12 dashes is 2 pi radians. So if I go 12 to the right, I'm off the graph. So I'm actually going to move and count 12 units to the left and plot a point. And then in this span, I should see 1 cycle. So now I kind of have these 2 points. In between those 2 points, the graph should cross the midline again. So 1, 2, 3, 4, 5, 6. If I split the difference right in the middle, I should cross the midline. And then in between these 2 points, I should have a high point and I should have a low point. So 1, 2, 3 in between, I'm going to hit that high point. 3 in between here, I'm going to hit that low point. So this would be 1 cycle. And here again, it was kind of where I wanted to start before. So 3 to the right, I'm going to hit the high point. 3 more to the right. I'm going to cross the midline. 3 more dashes to the right. And when I say 3 dashes, that's referring to pi over 2 radians. So pi over 2 radians to the right, I hit the max, another pi over 2 radians, cross the midline, another pi over 2 radians, the min, and the cycle would repeat. Again, I might want to test a point or two on this function. So let's check this point. Let's see if I've actually plotted it correctly. We would be here at, so this is 1/4 pi radians, pi over 2 radians. This would be 3/4 pi radians. So let's make a table. So what I've done here is I'm inputting 3 pi over 4 radians in for x into the function, and what comes out, so 3/4 pi minus 1/4 pi should leave me with half pi radians. So sine of pi over 2 radians is 1. 3 times 1 gives me out 3. So this should be the point on my function, and sure enough, at 3 pi over 4 radians, I hit that maximum value of 3. You could, again, graph this on your calculator, do a zoom trig as a check. And if you're just checking your homework, you can certainly do a second calc. So second calc value and input that 3 pi over 4 for x. And your calculator should spit out the y value too.